Okay. Hello, everyone. So my name is Kla Chakrit Tantitam Tawon. So I'm an SE discipline group lead at Monash University. It is my great pleasure to welcome you to the SE Lunch and Learn seminar series. I will begin by asking you to acknowledge the Wurundjeri and Burunong peoples of the Kulin Nation, traditional owners and custodians of the land on which we are meeting today, and pay respect to their elders, past, present, and emerging. And today we will have Ruoxi and Jason from the University of Adelaide. They will give a talk on the title When Software Engineering Meets Security and Privacy. Okay, so please give them a warm welcome and over to you now.
Yeah, so Ruoxi, please start.
Okay. Thank you everyone for your time and this great opportunity to share our research findings. And the topic is an empirical assessment of global COVID-19 contact tracing applications. Our paper have been accepted by the ICSE this year, and also the preprint version is available online via this link. Well, our motivation is quite straightforward. That is the rapid spread of COVID-19, which makes the traditional manual contact tracing very challenging, and the public health authorities turns to the digital contact tracing, that using apps to do the contact tracing. So considering about the urgent development period and also the potential very large scale deployment of such software, we are considering about the security and the privacy issues that may potentially raised by these apps. So here is an overview of our research. At first, we developed a tool named as COVID Guardian to automatically evaluate the security and privacy issues in the contact tracing apps. But actually, this tool can also be available to any kinds of the Android applications. And we apply our tool on 40 COVID-19 contact tracing apps that we collected from the very beginning of this pandemic. And we evaluate the security, potential security issues of these apps, including the manifest weaknesses and the vulnerabilities. We also look into if there are potential privacy leaks in these apps, and also check whether they have trackers and if they have malicious malware inside it. So after the security assessment, we continue to the privacy risk evaluation. And we identify 4 types of the potential threats to the contact tracing apps and give it a privacy evaluation. At last, we conduct a user study involving more than 300 participants. And we try to investigate into the willingness of using such contact tracing apps and their attitudes towards the privacy and data sharing. And also we focus on to collect their major concerns, such as why they're not going to use the contact tracing apps. So the final output of our research will be the weaknesses and the vulnerabilities we detected. And also we give some security recommendations to the software industry. And we collect the users' feedback and also provide some privacy guidance. Okay, so what is the contact tracing applications? Generally speaking, they are mobile applications that installed on a smartphone that can automatically record the daily contact of persons with each other. And once a user is diagnosed, he will upload the information to health authority, and the person that have been in contact with the diagnosed user will receive an at-risk alert to let them know that maybe in the last 2 weeks, he has been in contact with a diagnosed user. Normally, there are 2 types of the structure. One is the centralized system, and another is decentralized system. So for centralized system, the server will first assign tokens to users, and the user will exchange these tokens, such as an ID or a series of number that when they contact each other, that is normally in proximity of 10 meters. Yeah, and after they exchange their tokens, once a user, such as the user B in this diagram, once user B has been diagnosed, he will upload the token of A to the central server. And the server will do a matching and know who is get contact with B and send an at-risk alert to the user A to let him know maybe he is at risk. On the other hand, the decentralized system could be different. In the decentralized system, once the user B gets diagnosed, he will upload the token generated by himself to the server. Then the server only provide a download service to other users so that other users can download the token B and make a matching locally on his own smartphone. So this is the most differences between centralized and decentralized. And here are some examples, such as the Trace Together used in Singapore and also the OzSE used in Australia. They are all centralized system. And the Google and Apple provide a non-exposure notification protocol. So here are two examples of the apps that implement this protocol, which are the NHS COVID-19 in UK and the Corona Warn app in Germany. So here is the list. On the left are the list of the 40 applications we collected and involved in our assessment. They are from different countries worldwide. And the table on the right shows the assessment category and items we look into. The first category is the manifest weaknesses. We look into the manifest file and try to find whether they are insecure flag settings, such as whether the app allows data backup, and if there are non-standard launch mode for some activities, and if the apps allows clear text traffic. The second category is the security vulnerabilities. We try to find if there are sensitive data logged and if they are vulnerable to SQL injection, and whether any IP address are disclosed. And also, we check if there are hard-coded encryption key right in the code, and maybe there are some improper encryption algorithms used, and also the insecure random algorithm, also the insecure hash function. So they are, by examining these items, we may know whether if an application has security vulnerabilities. And we further look into the personal identifiable information to see whether there are potential leaks in the application, such as leak by a tracker. The tracker may collect users' information for business or advertisement. And we further look into whether there are potential leakage from sources to sinks. For example, if a user put PI data into a message, send it via message, that other application could also access to the message box, which means that such PI data could be leaked to other applications installed on the app, on the smartphone. Yeah. And last, we looked at the malware detection to see if there are virus, worms, Trojan, and other kind of malicious content inside these contact tracing apps. And here we make a very brief comparison between our two COVID Guardian and with the full state-of-the-art approaches in terms of the security and the privacy assessment. Yeah. Okay, here goes the overview of our methodology of the security assessment. Before we doing any analysis, we have a pre-processing approach. That is, after decompiling the APK file, we can get the XML file and also the Java code. So from the XML file, we can extracting strings that may contain PII data, such as some strings defined as full name, first name, second name. The strings will be defined in the manifest file or the layout file. And we also extract all the variables from the Java code and try to link the PII strings with the variables, such as a variable may defined as an added text, and its ID could be named as full name or detailed full name, something like this. So we can link the PII strings to the variables, and we got the PII variables, we call it as PII variables, as they may contain, has a very large probability contain PII information. So after the pre-processing, we start analysis. First one is the code analysis. We first look into the manifest file, and by parsing it, we check all the dangerous permissions and check if all the permissions are well protected. And we also check some configurations, such as allow to backup and allow to clear text storage. We check this too, the protection level and also the configuration. So they may expose some manifest weaknesses to us. And the second code analysis performed on the Java code. First, we identify all the trackers inside the application. This is easy. We just look into the third-party SDK they use. And then we extract all the methods, combining by the PII variables we identify in the pre-processing. So we can know which methods are using PII variables that they may contain PII data. Then we check whether this method is vulnerable or not. So if it is vulnerable, then this goes into the security vulnerabilities. Next step, we do the data flow analysis. So we generate the call graph of the app, and we doing a taint analysis on that to see whether there are PII data flowed from the source to sinks that may lead to a potential PII leaks. The last step is quite easy, that we utilize a VirusTotal, an online tool to scan malwares of the application, and we can find whether there are malwares or Trojan inside this app. Yeah. Okay, so here goes the results. I just list the key findings here, and we found that over 70% of apps use at least one of the old, or say, deprecated cryptography algorithms, such as MD5 and SHA1. They could be popular years ago, but now some evidence shows that they are not secure enough. And they may still be used in some third-party packages, and the developer just directly use them. But they may also bring security issues into their software. And another frequent weaknesses is clear text storage. Over half of the applications allow the clear text storage, which could leak the information of this app, or say the data of this app. Another issue is some apps set a flag allow backup to false. With this flag set up to, did not set the flag to false. So with this flag set up to true, a user may copy the data of the application through a USB debugging. That also means malicious users could extract data from the app. And over 3/4 of the app contain at least one checker. We found an app even have more than 8 trackers. And for the data flow analysis, the result shows that the top source of sensitive data are messages calling from location and database. So that means the location data and also the information inside database could be leaked. And most of the sensitive data will be transferred to sinks, such as the bundle and the surveys, and also the output stream, such as writing to a file or maybe storage in a SD card. These all are potential risk leakages of the PII data. And we found that some application, although it's not very huge amount, even transmit the location information through messages. As I just said, other application can also access to the message box. So that means they can obtain the location information there. And we are very happy to find that there is only one application containing malware. But consider the large-scale deployment of such application. That means maybe the whole country need to install this app. So this problem are still serious. Yeah. And we have disclosed our findings with the developers and also the some software industry company. After we disclosed our findings, 1 month later, we rechecked the new versions of contact tracing apps. It's very good to find that some issues has been solved, such as the trace together, the blue zone from Vietnam, and the stock COVID-19 from Spain, fixed the security issues. And also the application from Malaysia, they removed all the trackers in the new version. And the app, this app from USA contains more than 8 trackers. Is no longer available in Play Store. I think it has been removed. However, we also find some new vulnerabilities and that has been identified in the apps, such as the cross here. All the cross means there are new vulnerabilities found in the new versions. So we think that means the urgency of the app developments may impact the quality assurance procedures because the pandemic. So all the updates and the new versions must be released as soon as possible, and they may cause the quality assurance procedure maybe have some issues. Yeah, they did not check the app and before they release them. Yeah. So after the security assessment, we start a privacy risk evaluation. First, we identify 4 potential attacks to the contact tracing apps. First one is a linkage attack by the server. This may happen in some centralized solutions, as the data will be obtained and the storage in a central server, so that the malicious attackers, or say the health authority or government itself, can access to the central server and obtain all the data with which they can link back to the users to know who has been diagnosed. And then the second type is linkage attack by the users. So a malicious user could collect additional information and log them on a, say, software or a notebook. They can record the day, time, duration, and location whenever he met or contact with another person. And if one of the person got infected, the server will send at-risk message to the malicious user. And with the information he logged, he may link back to the user that to know who is got infected. And the third type of attack is the false positive claims, which is quite easy that the malicious user may claim he's infected, but actually he's not. So this is a false positive claims that will be sent to the server, and the server will send false alarm to other users he has been in contact with. So this will enlarge the range of alarm and with false positives. And the last attack is a relay attack, which may happen in the system that heavily rely on the Bluetooth broadcasting. So if a beacon has been broadcast in city A, and the malicious user may record the beacon, transmit it to another city, city B, and replay the beacon to let other users receive the fake broadcast. So once the user in city A got infected, the user in city B may receive an at-risk alarm, even though they have never been in contact with the A, actually. Yeah. So with these four threats, we further we start our risk evaluation. First, we evaluate the user's privacy exposure of each application. We define 5 levels. The first level is no data is shared with a server or user, which means their data a most secure level. But this is not the case for most of the systems. And then further we define 2 levels as medium level. That is the tokens. Tokens here means the non-PII data. That is the data not contain any personal identifiable information. Whether they shared with users or the servers, we define it as level 2 and level 3. And we have 2 highest risk exposure level. One is the PI is shared with the server. That is still, sometimes it's okay if we trust the server. And another one is the PI data released to public. Actually, this is shared by between users, which means that, for example, the location information is released to other users, then it's almost be released to public. So this is the highest risk exposure level. According to the result, most decentralized system, we give it a level as level 2 or level 3, as they did not share the PII information, but just share tokens between users and the servers. But for some centralized systems, such as the COVID Safe in Australia, and also the Trace Together in Singapore, as they collect the users' phone numbers and other PII information in their server. So we give it a level 4 exposure level. But notice that not every centralized system will be collect the PII information. For example, the Stop COVID in France, they only collect tokens in the server. So there are more secure solutions than the COVID Safe and also the Trace Together. One to note is that even the Honorary from Israel is a decentralized solution, as they release the diagnosed users' location information publicly. So we give the level 5 for the diagnosed user. Okay, then further we do the privacy evaluation against the 4 threats. The first threat, as mentioned, the linkage attack to server by server, mainly happens in the centralized systems, such as this one, this 2, and all there's centralized server, because the server may resolve some personal identifiable information. And the second one, the linkage attack by users, the system that exchange information between users may be vulnerable to such attack. And the third one, the false claim attack, although it is very easy to mitigate such attack, but we still find some system has no mitigation implemented. That means that any user can upload their information, even false positive information, to the server, and there is no authority procedure implemented. The last one, relay attack, mainly happens in the system that relies on the Bluetooth broadcast. So the broadcast beacon could be replayed or relayed and replayed in another city to make some false positive. And at last, we conduct a user study involved 373 volunteers residents in Australia. And we focus on the age group from 18 to 29, as it is reported that this age group could be more vulnerable to the pandemic, as they may like to join a nightclub or play around on beaches. That means they may contact more persons than other age groups. Most of them are from Oceania, and they're about 60% female, and more than 60% university graduates. And during the user study, we present 4 types of scenarios, privacy scenarios to them, as we don't like to mention the name of the application to avoid the bias. So type A and B are centralized solutions with or without PI data collected. And type C and D are decentralized solutions with or without PI collected. So they are most applications are covered by one of the 4 scenarios. And our questionnaire contains about 25 questions. They are all 5-point Likert scale questions. The scale will be like extremely unlike, somehow unlike, and somehow likely, or extreme likely, or another scale from the extreme unconcerned to extreme concerned. We have the 5-point Likert scale. And the questionnaire could be in pencil and paper, and we also provide online versions. We ask 2 groups of the questions. The first group is related to the likelihood of using, to ask them in one scenario that they are willing to use the contact tracing app or not, such as we have the functionality scenarios, to ask them if the system is perfectly accurate. Are they how likely are they to use the app, or if they are false positive or if they are false negative, whether they are still willing to use the contact tracing app. And we also provide some privacy scenarios, that is actually these 4 scenarios plus one with the perfect privacy preserving scenario to ask whether they would like to use the contact tracing apps. And another group question is concerns. We try to investigate into the concerns about why they are not going to use contact tracing apps. The concerns could be, it could include the usability, the effectiveness, or their concerns about the privacy. So here are the results. The first graph shows that if the system are perfectly accurate, there are about 60% of users would like to use the contact tracing apps, and not very surprised if there are false positive or false negative, the unlikely partial ratio will be increased. And we further look into the privacy scenarios. Here are the 4 tabs, A, B, C, and D, and we compare them with the perfect private scenario. So about 80% of users would like to use the app if their privacy perfectly preserved. But this is not the case in the real world. It's hard to avoid to make the perfect privacy preserve application. So we doing Whitney U test to see to compare the full the likelihood of using in full scenarios. The result shows that only tab C here, AC, BC, and CD. Only tab C has statistically significant difference from other 3 scenarios. That means the peoples are unlikely to use a contact tracing app, which is decentralized system with PII collection. So this is the best, this is the worst scenario. And for all the other 3 scenarios, there is no big difference. So at last, we ask questions about the concerns to investigate into the concerns of the user. The concerns include the battery drain and the storage drain, and also whether if the app are easy to use, and 2 points related to privacy issues and also the accuracy. So we find out that the privacy and accuracy are most concerned by the users. To conclude, we found out privacy design and tracing accuracy impact the likelihood of app use, because these two, if the system are perfectly accurate, the number is high. If the system are perfectly private, the number is also high. And the users are more likely to accept and use apps with better privacy by design. This is indicated by this the second graph. And further, if PII data has to be collected, the user prefer a centralized solution. And actually, this is the scenario A here, a centralized system with PII collection. Actually, this is the COVID safe we used in the Australia. So it turns out that COVID safe is still among the good applications, that users are willing to use. At last, to conclude, the contribution of this research is first we develop a tool that is the first tool able to automatically do the security and the privacy assessment on the contact tracing apps. As I mentioned, it also be available to any kind of the Android apps. And we do a security and privacy assessment on 40 contact tracing apps, and we identify full privacy threats against the contact tracing apps. And we conduct a user study over 300 participants to find out their concerns and the requirements to the contact tracing apps. At last, we disclose the findings to developers, and we do a regression test to check whether the issues are fixed, or we disclose our results. So in the future, we plan to look into the Bluetooth and the network traffic to see if there are more privacy information leaked. And we would like to expand our research to the iOS platform. Currently, we only check the Android platform. Okay, thank you. And if there are any questions.
Okay, thank you so much. Anyone has a question? So I think we have one question. I just look at the chat. What does PII stand for? Thanks for that. It is personal identifiable information.
Yeah.
So I have one like a simple question. Can you go to the slide 5?
Slide 5. This one.
Yeah.
Or
yeah.
Okay.
To my little knowledge, how do they exchange the token between the application? Is it like via Bluetooth or not?
Most of them via Bluetooth. Yeah.
Ah, okay, okay.
Actually, the two diagram I showed here are all based on Bluetooth. Yeah.
Okay. And can you go to the slide number 8?
Number 8, yeah.
Yeah. So this one, when you develop, no, when you analyze the code and the data flow and everything, do you use any tools or not? Or this is the tools that you develop by yourself?
Yeah, we did not build everything from the scratch. Actually, we utilize, I just write it down here, the Android Guard. This will help us to do something related to the manifest checking and also decompile and also can extract all the methods. And then we apply our rules on this extracted information to figure out the weaknesses and vulnerabilities. Yeah. And for the data flow analysis, we relies on the name is FlowDroid. Yeah, we have some modification on the FlowDroid to extract the potentially PI leaks. Yeah.
I see. What about the malware detection?
Oh, this is quite easy. We just utilize the state-of-the-art VirusTotal. This is an online tool that can combine more than 60 malware engines to check if there are malware or Trojans inside an app. Yeah.
I see.
Yeah. So
interesting.
Yeah, our efforts are mainly these parts. Yeah.
Okay.
And also this part. Yeah.
Okay. So I have one question. Another question is that I saw lots of people work on the malware prediction, malware detection. So what do you think about this? Like a compare between the machine learning approach to detect malware and compared to the VirusTotal?
Well, the engines in VirusTotal, I don't think they are all using machine learning approach. The state-of-the-art machine learning approach could be the driving. I'm not sure if I not spelling it good. It using a very simple method that extract features from the manifest file and also the Java code, and they implement SVM model to do the classification. But as you know, any machine learning model could be vulnerable to like backdoor attack or adversary attack.
Okay.
So there also plenty of the research shows that the machine learning model could be vulnerable to these attacks. Yeah.
Wow. Okay. I see.
Yeah.
Yeah.
But there's still a lot of work could be done about the machine learning approach. Yeah.
Right.
Yeah.
So one thing is that I am this is more like a static approach, but I'm just wondering if there is a way that we can develop a machine learning to detect this kind of thing or not, and how accurate they are.
Yeah, I think the key part, it depends on how the feature is extracted. Because the machine learning part, we could just borrow something from the machine learning domain, such as a model. But how to extract the feature could be a kind of difficult problem. Yeah.
I see. Okay. Maybe I can go to the next question. Big, you mentioned some question about the 22%. You want to speak about that?
Right.
Okay. She is not available now. Okay, can't talk. Okay, maybe I can ask for her. So she mentioned about the 22% in the user study.
22% in the user study.
Yes.
The
slide 14, I think.
14.
Yes. So I think for the perfectly private, right?
Here.
It is quite surprised that there are 22% of the respondents who are not likely to use the app at all. So
Yeah,
do you have any comment or insight about that? Do you ask like open questions or not? Yeah.
We did not, but I think they could be someone just don't like the contact tracing app. Maybe even the private part is perfectly, then they may have concern about the accuracy part. Yeah.
I see. Yeah. They may not want to use the COVID app at all. Maybe. Yeah. Right.
Actually, we are a little bit surprised about the 78% that when the privacy is perfect, they would like to use. I think the number is really high. Yeah.
Yeah. I think another thing is that I'm quite surprised how much the background knowledge that the respondent must have to fill the survey form as well. Like it looks like they should have some privacy or security background a little bit.
Yeah. Actually,
right?
we give a very short introduction before they answer the question. Yeah.
I see. Yeah, that's interesting. Yeah, that's really good. Okay, maybe the next question. It is stated in the contribution that the authors developed COVID Guardian, but I did not see the speaker presenting about this. I think COVID Guardian is like the combination of all techniques, right? Three aspects into one. Yeah. Yeah, this one, the code analysis, data flow, and the malware.
Yeah. And we also released our code in GitHub. So if you go into this link, and we have a link of website on our paper, and you can find the source code. Yeah.
Nice. Yeah, that's really useful. Yeah. Wow. I think this work is really interesting. It's like a breakthrough. Have you got any news cover for this work?
Yeah, there are some say prize online by the mainstream media. Yeah.
I see. Okay, good. Anyone else? Questions? Xinglian? No. Okay. Then no questions. Gerard, do you have any questions or not? Nope, sorry. Okay. No questions, no more questions. Okay, then thank you so much for coming. Yeah, well done. I really like your work. Yeah.
Well, thank you so much.
Yeah. So how far are you now? Your PhD, first year, second year, or third year?
First year PhD.
First year. Wow. Fantastic. Yeah. You got an ICSE paper. Yeah. Wow. That's cool. Okay. And what is the next step? Like, what do you plan to do next? Yeah. You talk about Bluetooth, that one?
Yeah, maybe look into another domain of the mobile applications, and also check the security and privacy issues. Yeah.
Okay.
Yeah.
I see.
So yeah, my PhD topic is related to the mobile application security and privacy. So yeah.
Yeah, that's cool. Okay. And then that's it. Jason, do you have anything that you want to close or not?
Maybe yes. Maybe I'll take a 5-minute talk, and then let's have a QA, right? So
yeah.
Let me discuss. Okay, so let me check how can I share the screen. Share screen. All right.
Yeah.
Okay, so now Ruoxi just give me 5 minutes. So, okay, so when SE meets AI in cybersecurity, so Ruoxi talk about SE, which I really don't know about SE, you know. I'm a security and privacy guy. So the first part has been done by Ruoxi. So I go with the 1984, George Orwell. There are 3 slogans. And then Google is always watching you. And what does Google know about you? Your web searches, websites, everything, the videos you watch, the content of your emails, everything, right? So what are the third parties? Or hackers, government brokers, data brokers, friends, mafia, they're all third parties. And data brokers usually know a lot of things about you because they try to profile you and try to use your privacy information to infer the information that they want. So, and this is my narrow view of cybersecurity, which I currently working on. So the first part, inference attacks, there are 4 models, and I'm working on each of one, and all the papers are on the submission. In AI security, there are some attacks there, poisoning, backdoor, invasion. And there are several papers will be accepted this year. And data privacy, privacy enhancing technologies. This is part of Ruoxi's stream. And Android and iOS vulnerabilities, last year we got a paper in the iOS network service vulnerabilities study there. And internet security measurement, which I started this is the topic that I started when I was a PhD. So, and these are not too recent projects. I mean, I try to, because of the time limit, I try to start from the location privacy and then go to the right to proposal law and search engine stuff. So maybe I'll introduce a little bit. So these are the categorization of location-based social discovery services. WeChat, it reported, there's a people nearby service, and the distance is reporting banned. But Yik Yak is kind of an anonymous social network. There's no reported distance there, but even all of them, regardless of band distance or vaguely nearby service, you can always pinpoint the users when people querying the people nearby service. When people use the location-based service, then we always can pinpoint these users' location. And by this research, and the Yik Yak company has went bankruptcy I think in 2016. So once valued at $400 million, it shuts down the sales of engineers for $1 million. So I'm sorry, Yik Yak. Because Ruoxi and I, we are the internet privacy whistleblower. We always whistleblow the things that didn't do well or didn't do what they intentionally to do. So, and then we try to whistleblow these things. And the another issue is the right to be forgotten law. This is when people try to Google your name on Google about your historical versions or about anything happened previously. But in European countries, you can try to submit the link to the Google committee and then try to delist the link that will appear on Google in EU domain. So this began in May 2014. So European citizens can submit the web-based form, your name, citizenship, URL you want to remove, or justification. And Google, there's a committee there, will check whether you satisfy the following 4 items, and then they will try to delist it. And then, for example, so if Google grants a request from Joe Doe to delist an article about a trip to Shanghai or Melbourne, Google will not show the URL for queries include Joe Doe, but Google in EU domain will show URL for query like trip to Shanghai. Okay, so Google doesn't have the right to delist the article actually, but he has the right to remove the article when you're querying your name in the search result, in the Google search result. Okay, so the article is still there, but Google has the right to decide whether you can search it or not. So basically the law, RTBF, right to be forgotten law, doesn't affect the original published content because they don't have the right to remove the publications on BBC. They don't have the right. So links remain still listed on google.com. So this is the background for this research. But our main result for this study is with moderate resource and hacking skills, everyone or a transparency activist can determine these delisted URLs and the names of the people who requested the delisting. So we basically can determine the links delisted and the requester of these links. So, and this can lead to the strengthening effect, which means that there's a phenomenon whereby an attempt to try to hide the information, but consequently got the unintended consequence when you publish the information. Okay, this is kind of a side effect when you try to hide the information, but ultimately you got more exposure for this kind of information. This is called a strengthening effect. And this kind of study put the efficacy of the right to forgotten law into question. So, and this is the kind of the strengthening effect when people, when request the list of links on a day 0, and then after that, the Google Trends and Twitter will have a spike and just several days after the requesting. Okay, so this is kind of a whistleblowing for the law legislation itself. And then I think I'll stop here. Yes, and this kind of study I try to study, and also Ruoxi tried to continue this whistleblowing things, but in the more software engineering domain.
I see.
This is, yes, right.
Wow.
Yeah. Any questions?
Yeah, I think, yeah, the last your presentation looks really cool. This is like a new angle to me. Security, AI, and the internet, that kind of thing. Yeah. Is it like something that is popular in the CCS domain at the moment?
It depends. So yes, it depends how this study is impactful. So how impactful the study is, or how, yes, and also depends on the consequence, the results that you studied. So for like COVID stuff, you try to whistleblow the government's rollout of these kind of COVID safe applications, and you get some interesting ideas in the results. And I think it's useful for the whole society. And then that's why we shipped the paper to ICSE. And yes.
I see. Okay, I see. And how about the DP, your DP? Is there something?
Oh, DP, I didn't submit it. So,
What about the one in the previous year?
Oh, the previous one.
The successful one, is there something around this area or not?
No, the successful one about the cryptography, synthesis and generation stuff.
Okay.
Yes.
Okay.
Yes.
Okay. I see. Okay. That's good. Yeah. Thank you so much. Okay.
No problem.
Okay.
I'm very happy
thanks a lot.
be
Yeah, thanks a lot for your time preparing the talk. Yeah, I think we learned a lot today. Yeah, this is like a new angle, a whole new world for me.
All right.
Right. Big, do you have anything you want to talk or not? I think you are free now.
Hi, hello.
Hi.
Hello. Sorry, I just take my son to bed during your talk. So first of all, thank you for your talk. You take him, your talk make my son sleep.
Oh, thanks.
Yeah. So no, but for about the work is I don't have any other questions. I just want to say thank you, and it's very nice talk, and it's very interesting topic. Yeah. Thank you very much.
Okay, and looking forward to seeing you in Melbourne.
Yeah, same.
Definitely.
Yeah. Just let us know when you drop by Melbourne. Yeah.
Yeah, and let us know if you have any job openings for both of us.
Okay, sure. Okay, sure. Yeah. Okay.